Significant figures or digits are critical when reporting measurements and performing calculations in chemistry. When recording measurements, the value is only an approximation because measuring devices are never completely exact. Therefore, there is some level of uncertainty. Due to this uncertainty, significant figures are used to denote the numbers that are known to be certain plus one digit of uncertainty. Let's take a look at a list of rules summarizing how to determine which digits are significant. The first rule states that all non-zero digits are significant. For instance, 1.86 grams has 3 significant figures and 2 significant figures are present in 5.1 centimeters. Secondly, zeros that are between significant figures are significant. Therefore, 3.908 milliliters has 4 significant figures, and 7.02 grams has 3 significant figures. The next rule explains that a leading zero that is to the left or before the first non-zero digit is not significant. For example, 0.09263 milligrams has 4 significant figures, and 0.0042 meters has only 2 significant figures. The fourth rule expresses that terminal zeros that are to the right of the decimal point are significant. In the temperature reading 34.70 degrees Celsius, 4 significant figures are present, and in the value 0.410 grams, there are 3 significant figures. Lastly, terminal zeros to the left or before the decimal place may or may not be significant. Writing the value in scientific notation will help avoid this rule's ambiguity. By writing 313,000 miles as 3.13 multiplied by 10 to the 5th miles, the scientific notation represents 3 significant figures. The next example shows 6,200,000 kilograms written as 6.2 multiplied by 10 to the 6 kilograms, which represents 2 significant figures. Now that we have reviewed the rules for determining significant digits, let's work through a few practice examples. How many significant figures are in each value? To determine the number of significant figures, refer to the list of rules for determining significant figures. For problem number 1, there are 3 significant figures because according to the first rule, all non-zero digits are significant. Number 2 has 4 significant figures. The numbers 4, 9, and 1 in this value are significant according to Rule 1. The 0 is a significant figure because the second rule states that zeros located between significant figures are considered significant. Next, let's look at problem number 3. The numbers 1 and 2 are significant by rule number 1. According to the second rule, zeros that are between significant figures are significant. The third rule states that leading zeros are not significant. Thus, these 4 zeros are not significant. Their only purpose is to locate the decimal point. Therefore, the number of significant figures in this value is 3. For problem number 4, all non-zero digits and zeros between significant figures are significant. According to Rule 4, terminal zeros to the right of the decimal point are considered significant. Therefore, the total number of significant figures is 5. Notice that for problem number 5, the value does not have a decimal point. Since there is no decimal point and there is no information given regarding the measuring device used, the 0 in 240 may or may not be significant. Writing the value in scientific notation will help avoid misinterpreting the wrong amount of significant digits. Using scientific notation, this value has 2 significant figures. Next, let's determine the number of significant figures in the final problem. 7 and 1 are significant figures. According to rule number 2, zeros between 2 significant digits are significant. Rule number 4 states that terminal zeros to the right of the decimal point are significant. As a result, these 2 zeros are significant, which gives a total of 6 significant figures. For the last example, this number has a total of 7 digits, but some digits may or may not be significant. Let's figure out which digits are significant figures. Notice that there are 4 choices for the number of significant figures. Which option is correct? Let's take a look at option A. According to rule number 3, a leading zero that is before the first non-zero digit is not significant. Therefore, these zeros are not significant, which causes option A to be incorrect. Option B states that there are 2 significant figures present. According to Rule 1, all non-zero digits are significant. Therefore, the 3 and 7 are significant. However, keep in mind that there are ways for zeros to be significant figures. According to rule number 2, zeros between non-zero digits are significant. Therefore, the 0 between the 3 and 7 is significant. This causes option B to be incorrect. Rule number 4 states that trailing zeros to the right of the decimal place are significant figures. Therefore, the trailing zeros are significant. This causes option C to be incorrect, which leaves option D 5 significant figures. After counting the total number of significant figures, this is the correct answer.